Hello students, our next topic is block and wedge. Here we will be including the friction. So this is our wedge, theta is the angle of the wedge and m is the mass resting on the wedge. The coefficient of friction is mu. For wooden blocks mu is ranging from 0.2 to 0.5. So we have to find the value of theta at which the block starts to slide and the acceleration x double dot, which is the acceleration along the x direction when it starts sliding. So this is our mass m resting on a wedge of angle theta, and here w is the weight of the block, and here too this angle theta, and this F is the friction acting opposite to the direction of motion. The mass begins to slide in this direction, which is the x direction, and this is the y direction where normal reaction, which is perpendicular to the surface of the block and the contact surface, which is perpendicular to the contact surface, normal reaction is acting. So we have to find out the value of theta at which the block starts to slide and also the acceleration x double dot. So we resolve w into its two components, w cos theta and w sin theta. So w sin theta is opposite to friction and w cos theta is opposite to normal reaction. So we can write down the equations of motion. So in the absence of friction, the block would slide down the plane. So if there is no friction acting in this direction, this will probably slide along the plane. Hence, the friction force F points up in the plane. With the coordinate shown, we have the first equation mx double dot, which is the x component of the force. X is this direction, this is x direction. So mx double dot is equal to w sin theta minus f. These are the two forces acting along the x direction. So it is w sin theta minus f. F is the friction force. Okay. And what is the equation for force along the y direction? My double dot is equal to n minus w cos theta. So n minus w cos theta. The value will be equal to 0 because there is no movement along the y direction. So this value is equal to 0. Now when sliding is just about to start, F has its maximum value, which is equal to mu n. We have found in the notes the value of maximum friction is equal to mu n. At that point x double dot is equal to 0. So for the maximum value, the time variation will be 0. Therefore, the equations will be, when we substitute x double dot is equal to 0, y sin theta maximum theta for which that is equal to mu n, and the second equation will be w cos theta max is equal to n. Hence, on dividing these two equations, you get a relation between angle theta and the friction. Tan theta maximum is equal to mu. Mu is the coefficient of friction. As the wedge angle is gradually increased from 0, the frictional force grow up in magnitude from 0 to a maximum value. Okay, which we know that friction force grow from 0 to a maximum value of mu n since before the block begins to slide. So we have just before it is sliding, the value of F will be W sin theta, when theta is less than or equal to theta max. So this is the value when it just begins to slide. So once the block is sliding, its acceleration is given by mx double dot is equal to w sin theta minus mu w cos theta, substituting for the value of friction. So the acceleration x double dot is equal to, substitute w is equal to mg, m get cancelled throughout. So you get g into sin theta minus mu cos theta, that is equal to x double dot, the acceleration of the block along the x direction. Now the physical dimension of the right hand side is that of g, acceleration, while the left hand side is also x double dot, which is also acceleration. So both sides are of acceleration dimension. So the equation is dimensionally correct. However, it is a good practice to look at the behavior for various values of the parameters. In this case, for various values of mu, what will be the variation? When mu is small, so there is a less amount of friction if it is exists between the two surfaces. The acceleration will be, so mu, if it is very less, is somewhat less than in the absence of friction, which is to be expected. So when we find out when if it is more than if mu is very high, we expect the acceleration, the motion to be upward direction. The block will start to move upward direction. That will be uh, the second case. Okay.